Elasticity in solids refers to the ability of a material to return to its original shape and size after being subjected to a force or stress, and then having that force or stress removed. This property is key in many materials we use in everyday life, such as rubber, metals, and springs, where the material can deform under stress, but then recover once the stress is released. When an external force is applied to a solid object, it will deform, stretch, compress, or twist. If the material is elastic, it will return to its original shape when the force is removed, provided that the force did not exceed the material's elastic limit. The elastic limit is the maximum amount of stress or force a material can withstand while still being able to return to its original shape. If the stress exceeds this limit, the material may undergo permanent deformation, entering the plastic region, where it does not return to its original form. Elasticity is usually quantified by two key measures: stress, which is the force applied per unit area within materials measured in pascals, Pa, and strain, which is the deformation or change in shape due to stress, a dimensionless quantity that is the ratio of change in length to original length. For many materials within their elastic limits, the relationship between stress and strain is linear. This relationship is described by Hooke's law, where stress is equal to Young's modulus multiplied by strain. This means that for small deformations, the stress is proportional to the strain. There are different types of elastic deformations. Tensile stress occurs when a material is stretched, compressive stress occurs when a material is compressed, and shear stress occurs when a material is subjected to forces that cause it to twist or shear. Different materials exhibit varying degrees of elasticity. Rubber is a highly elastic material, able to stretch and return to its shape easily. Metals generally exhibit elasticity, but with limits. They return to their original shape after deformation as long as the stress is below their elastic limit. It has a certain degree of elasticity, but it is less than rubber or metals and is more likely to deform permanently under stress. In summary, elasticity is an essential property for materials that are required to endure forces and stresses without permanently changing shape, which is important for various engineering applications, like designing bridges, vehicles, and other structures where materials must withstand forces without losing their original shape or functionality.